In this lesson, we're going to be given information about a number and try to figure out what that number is. We're going to practice writing and solving equations without using algebra tiles. Fill in the notes as we answer each question in the video. We will go over a few examples together, and then you're going to try solving problems with your group. So together, we'll do problems 1, 2, 4, 6, and 7. In your groups, you'll do 3, 5, and 8. At the end of the packet, I have a couple more practice problems that you will work on with your group, okay? So let's start with the first example. So we'll be given information about my number, okay? And then we'll be tasked with writing and solving an equation based on the information we have. Okay, so it says when I triple my number, and I'm going to put that in quotes, then add 4, I get 10. So when I triple my number, okay, I don't know what my number is right now. So whenever we don't know what a number is in math, we just use a variable. And in this case, we'll use x. So when I triple x, okay, whenever I'm tripling or doubling or like quadrupling, I'm just multiplying. So triple would be multiplying by 3. So when I triple x and then add 4, I get, and whenever you see I get, that's going to be equals. Okay, I get, so equals 10. So now I'm going to go and solve this equation. So we aren't going to be using algebra tiles, but we can still think about this in terms of algebra tiles. So if this is on an equation mat, on one side of my mat I have 3x plus 4, and on the other side I have 10. So I have 3x tiles and 4 unit tiles on one side, and 10 unit tiles on the other side. So I can take away 4 unit tiles from both sides, that idea of those balanced sets. So I'm going to represent taking away 4 from both sides with subtraction. Okay, so I'm going to subtract 4 and then subtract 4. Okay, so now if I remove the 4 from that side, okay, I'm left with no more unit tiles, no more 1s, so I just have 3x. And on the other side, 10 minus 4, that's 6. So in the previous step, I was adding 4. To undo the addition of 4, I subtracted 4 from both sides. Now I have all of my x tiles, or my x terms, alone on one side of the equation. Okay. It's also important to understand that 3x is really 3 times x. So up here, we were doing the opposite operation. So the opposite of adding 4 is subtracting 4. Down here, we're going to do the opposite operation as well. The opposite of multiplying by 3 would be dividing by 3. So I'm going to divide both sides by 3. Okay? So 3 divided by 3 is just 1. So 3x divided by 3 is just 1x, or we usually just write it as x. Okay? And then 6 divided by 3, that's 2. Okay? So x equals 2 is my final answer. And to check to see if that answer is correct, I'm going to replace the x in my original equation, 3 times x plus 4 equals 10, with the answer I just got, with 2. Okay? So 3 times 2 is 6. And I bring that plus 4 down, equals 10. And then 6 plus 4 is 10. And of course, 10 equals 10. So that checks out. So that means my answer is correct. Okay, let's try another one. Okay, so similar problem here. It says when I double my number, okay, so doubling my number, that would mean multiplying my number by 2. And remember that my number, that's just going to be x right now. So multiply x by 2, 2x. Then add 6 plus 6. I get, whenever we see that I get, I know that I'm going to be using an equal sign. My number, it says numby, but it should say number. My number, which is once again x, plus 7. So this problem's a little bit different because I have an x tiles over here, x terms over here, and x terms over here. When in the previous problem, I just had x's on one side. But that's fine, okay? Handling that is pretty simple. So the first thing I want to do is I want to move all my x's to one side of my equation, okay? So just like in the previous problem, when I took the 4 and got rid of it, I'm going to get rid of the x on both sides, okay? So what do I have in common on both sides? Well, I can get rid of one x. So I'm going to subtract an x from both sides. Okay, if I take away an x from both sides, I don't have any more x's on the right side. And I take away an x from 2x, I'm just left with 1x. All right. So now I got to take care of my ones, or my whole numbers, my unit tiles. Okay, so how many unit tiles can I take away from both sides? Well, I have 6 over here and 7 over here. So I can take away 6 from both sides, and I represent that by subtracting 6. Okay, 6 minus 6 is 0. I don't have any more unit tiles over there. I just have x, and that's equal to 7 minus 6, which is 1. So then my answer is x equals 1. Now, to check to see if that's true, I'm going to rewrite my original equation, but I'm going to replace all the x's with 1. So instead of 2x plus 6, it's going to be 2 times 1 plus 6 equals, instead of x plus 7, it'll be 1 plus 7. Okay, 2 times 1 is 2. So then I rewrite the rest of my equation there. So now I have 2 plus x equals 1 plus 7. Or excuse me, 2 plus 6 equals 1 plus 7. Okay, 2 plus 6 is 8. And 1 plus 7 is 8. Okay, so that checks out. 8 equals 8. So that means that my answer of x equals 1 is correct. So now we're going to move on to the third problem. So the third problem looks kind of weird on my screen, but it should look more organized on your outline. So problem number 3 is one of the problems that you will be completing on your own. So at this time, please pause the video. We'll give you a couple minutes to work through that problem. So at this point, we've had some time to try number 3 on our own, work in our groups. Let's quickly go over it as a class so you can check your answer. So when I double my number, then add 5, I get 17. So doubling my number, 2 times x, then adding 5, I get 17. Okay, so that's kind of the first step, is actually writing the equation. Now then the second step is just to solve. Okay, so I look at what can I take away from both sides. Okay, well if my goal is to get all my x's by itself, I would need to take away 5 from both sides. So I'm going to subtract 5 from both sides. Okay, I take away 5 from the left side. I'm just left with 2x. And 17 minus 5, I get 12. Okay, so remember, when I have a variable and a number, just like I do here, that's really 2 times x. Okay, up here, to undo addition, I subtracted. Down here, to undo multiplication, I'm going to divide. Okay, so before we use the division symbol like that, okay, but we can also use fractions. Okay, so we can also write it like a fraction. So divide by 2 on both sides. Okay, 2 divided by 2 is just 1. So 2x divided by 2 is just x. And then 12 divided by 2 is 6. Okay, and if you check your answer, I'm going to rewrite that equation, and instead of x, I'm going to write 6. So 2 times 6 plus 5 equals 17. Okay, 2 times 6 is 12. Bring the plus 5 and the 17 down. And then now I have 12 plus 5 equals 17. Okay, 12 plus 5 is 17. So 17 equals 17. Checks out. That means that my solution of x equals 6 is correct. Okay, moving on to problem number 4. So we're going to do problems 4 and 5 together, and then you'll have some time to work on problem 6. So with these next few problems, we're just going to have a couple more steps. Might make things a little bit more complicated at first, but not any more difficult. So the first step, it says when I double my number, then add 3, then subtract my number, then subtract 1, I get my number plus 2. There's a lot going on there, but we're just going to go through it one step at a time. Okay, first step, it says double my number. Okay, so at this point, we should know that doubling my number, we write that as 2x. Okay, and then I'm going to add 3, so just plus 3. Then it asks me to subtract my number. Okay, well again, my number is x, so I'm subtracting x, and then I subtract 1, so minus 1. Okay, and then I get, so whenever I see I get, I know that means equal, so I get my number, which is x plus 2. So before I start to add or subtract from both sides, I'm just going to look at each side individually to see if there's anything that I can simplify. So I'm going to look at the left side of this equation here. 2x plus 3 minus x minus 1. So I'm looking for like terms. Okay, well I see that I have a 2x here, and I'm subtracting x here. So if I have 2 x tiles, and I take away one of them, well, then I'm just left with x, okay? So I just have 1x on the left, and then I have a positive 3 minus 1. So those are also like terms. So then I can do 3 minus 1. Okay, so 3 minus 1, that's 2. So I'm doing adding 2. Okay, and that's equal to x plus 2. So there's nothing else I can combine on either side of the equation, okay? If I wanted to, I could move stuff, but something interesting just happened. Okay, so I have x equals 2, or excuse me, x plus 2 equals x plus 2. Okay, so we should see that both sides of the equation are the exact same. So no matter what value for x I plug in, the equation will be true. So that means that this equation has infinitely many solutions. So we can say x can be any number. Okay, x can be any number. Okay, infinite solutions. All right, whenever we get to a point where the left and the right side are exactly the same, infinitely many solutions. So now I invite you to try problem number 5 on your own. Okay, so you'll try this one, and after a couple minutes, we'll come back together and go over the answer as a group. So number 5 says, when I double my number, then subtract 3, then subtract my number, then, sorry, this got cut off a little bit for me. Let me zoom out just a little bit. Okay, then add 4, I get my number plus 2. Okay, so again, a lot going on here, but if we just break it down step by step, it's not too bad. So the first step is to double my number, so that would be 2x. And then I subtract 3, so minus 3. Then I subtract my number, so minus x. Then I add 4, plus 4. Okay, whenever I see the I get, I know that means I need to insert my equal sign, and then my number plus 2, so x plus 2. So similar to the last problem, I can do a couple things with the left side of my equation to make it simpler by combining like terms. So I see I have an x term here and an x term here. So I have 2x minus x. Okay, so 2x minus x. Okay, 2x minus x is just 1x or just x. Okay, I also have a couple of constant terms. That means terms without variables. I have negative 3 plus 4. So negative 3 plus 4, I combine that, I get plus 1. And that equals x plus 2. Okay, so you might see it right away. Okay, you might see that there's something that looks kind of weird about this problem, but let's just take it one step further. So again, I'm looking for balanced sets, okay, things that I can take away on both sides that are the same. And in this case, I have an x on both sides, so I can take away x, once again, using subtraction to represent taking away tiles from both sides. So those are equal to 0. And then I'm left with 1 equals 2. Okay, clearly 1 doesn't equal 2. That equation is not true. So whenever I'm solving an equation, I get to this step here, okay, where the left and the right side of my equation are not the same or not equal, okay, and there's nothing I can do to make that equation true. Well, then I just say that this equation has no solutions. So remember, a solution is a value for x that can make the equation true. In this case, no matter what x I plug in, my equation up here will not be true. So that means there is no solution. So just to do a quick recap, we've seen examples that have one solution, like x equals 2, okay, x equals 1, okay, x equals 6. Okay, we've seen an equation that has an infinite number of solutions, and we've also seen an equation that has no solutions. So those are our three options when we're solving an equation. We can have one solution, no solution, or infinitely many solutions. So let's move on to example 6. So this one says, when I add 3 to my number, then double it, I get 14. So this one's a little bit different. In the previous examples, we've always doubled our number first, but this time we're adding 3 first. So let's just start there. When I add 3 to my number, x plus 3, then double it. Okay, so when I say it here, I'm talking about this entire thing. Okay, so I'm talking about not just x, I'm talking about x plus 3. Okay, so I double that, I multiply that by 2, and then I get 14. So now I have a number out in front of some parentheses. Okay, so now I have to use a certain property that we've talked a little bit about called the distributive property. And so that means that I'm going to take the number in front and multiply it by everything inside the parentheses. So I start with 2 times x. Okay, 2 times x is 2x. I'm going to bring that plus down. And then 2 times 3 is 6. So I have 2x plus 6 equals 14. Now I have to ask myself, what is the same on both sides? What can I take away from both sides? In this case, I can take away 6 from both sides. So minus 6 and minus 6. When I do that, I'm left with no 6's over there. That becomes 0, so I just have 2x. And that's equal to 14 minus 6, and 14 minus 6 is 8. Okay, once again, a number and a variable, that means 2 times x. So to just get x by itself, because that's what I'm doing here, I'm solving for x, I need to divide by 2 on both sides. Okay, 2 divided by 2 is 1, so then 2x divided by 2 is just 1x, or just x. And then 8 divided by 2 is 4. Okay, so now I want to check to see if that answer is actually true. So I'm going to rewrite my original equation, 2 times x plus 3 equals 14. And instead of x, I'm going to write 4. So I have 2 times x plus 3. So now it's going to be 4 plus 3 equals 14. Okay, so I just took this x and plugged it in there. Okay, so I look at what's in parentheses first. Okay, so in parentheses I have 4 plus 3. I know that 4 plus 3 is 7. Okay, and now we have 2 times 7 equals 14. Okay, 2 times 7 is 14. 14 equals 14. So that is true. Okay, so because this equation is true, I know that x equals 4 is my actual solution. So now let's try problem 7. Okay, so problem 7 is similar to the last problem that we just did, because I add 10 first and then triple it. Okay, when I do that, I get 21. So let's start with that first bullet point. I'm adding 10 to my number. So x plus 10. And then I triple it. Okay, so in this case, it means x plus 10. Okay, so to triple that, I use my parentheses and I multiply that whole thing by 3. So I add 10 to my number and then triple my number. Okay, and when I do that, I get 21. So we're going to go through and solve this in a very similar way to how we solved number 6, okay, by using the distributive property. So my first step is I have to distribute this 3. Okay, so I do 3 times x first, which is 3x. And I bring that plus sign down. And then I do 3 times 10, which is 30. And that equals 21. So this whole time, in all these problems, I've been trying to get x by itself. Okay, so I just want x on one side and everything else on the other. Okay, so to do that, I need to undo the adding of 30. Okay, so the opposite of adding 30 would be subtracting 30. And I have to do that to both sides. Okay, when I do that, that becomes 0. I'm just left with 3x over here. And that's equal, okay, 21 minus 30. So I'm subtracting more than what I have. So I'm going to be in the negative. So negative 9. Okay, and whenever we've gotten to a step like this so far, we've always been dividing by the number in front of x. Okay, and this is going to be no different. I'm going to divide by 3 on both sides. Okay, 3 divided by 3 is 1. So 3x divided by 3 is just 1x, or just x. Okay, and then negative 9 divided by 3. Okay, a negative divided by a positive is going to be negative. Okay, and 9 divided by 3 is 3. So that answer is x equals -3. All right, and then once again, I'm going to go through and check my solution quick. So I'm going to take that original equation I wrote at the very start of the problem, 3 times x plus 10 equals 21, and I'm just going to replace that x with my -3. So it's going to be 3 times -3 plus 10 equals 21. Okay, so I'm going to do what's in parentheses first. So I'm going to do -3 plus 10 first. Okay, -3 plus 10 is 7. So now I have 3 times 7 plus 21. 3 times 7 is 21. So 21 equals 21, which of course is true. So that means that the answer I got down here checks out. X does in fact equal -3. So the last two examples that we did, we had to use the distributive property. Okay, so this example is probably going to be no different. So try this one on your own. Okay, use the last two problems to guide you, and of course, work in your groups. We'll come back as a group in just a couple of minutes to talk about number 8. So number 8, I add 4 to my number, then double it, and when I do that, I get my number plus 2. So first step, add 4 to my number, and then I double it. Okay, after that, I get my number plus 2. So x plus 2. So once again, I'll be using the distributive property. So the first step would be 2 times x, so that's 2x. I bring my plus sign down, and then I do 2 times 4, which is 8. And that equals x plus 2. Okay, so I have variables on both sides. I have 2x over here and x over here. So I'm looking at what can I take away that's the same on both sides. Well, I can take away an x. Okay, when I do that, I have no more x's on the right side, and 2x minus x, so 2x take away one of those x's, I'm just left with 1x or just x. And then I get x plus 8 equals 2. Okay, last step here. Okay, again, when I'm solving an equation, I want to get x by itself. So right now I have x plus 8, so I got to figure out a way to undo the plus 8. So I will subtract 8, and I got to do it to both sides. Okay, when I do that, I'm left with no more 8s, or no more constant terms on the left. I just have x. And then 2 minus 8. Once again, I'm taking away more than I have. So 2 minus 8, that's -6. Okay. So I'm just going to check my answer quick. So wherever I see an x in that original equation, I'm going to replace with -6. So I have 2 times -6 plus 4 equals -6 plus 2. So I'm going to do what's in parentheses first. Okay, so I do that first. -6 plus 4, that's -2. So then I have 2 times -2 equals -6 plus 4. So 2 times -2. Okay, a positive number times a negative number, it's going to be negative. So 2 times -2 is -4. And then -6 plus 2. Okay, that's also going to be -4. So that works, that checks out. So that means that this is my real answer. So the rest of these problems, okay, solve the following problems with your group. Reminder, Do not move on until all members of your group have answered the question. Okay, work as a team. Okay, work as a team. Write an equation based on the information given, then solve the equation. Show all your work. So just like we have been doing. Okay, so you will solve the rest of these problems on your own with your group. I'll have an answer key up front. You can check your work as you go or check it at the very end.